Welcome to Kushagra Academy, Unleashing Potential. Class 9, Chapter 1, The Language of Chemistry, Part 3. In this part, we will study about the chemical equation, about the chemical reaction, about balancing of the chemical equation and why we balance the chemical equation, what are the information we can get from the chemical equation, and about the molecular mass and the relative atomic mass. So, we will start with the chemical equation. So, what is chemical equation? It is a symbolic representation of a chemical reaction using the symbols and the formula of the substances involved in the reaction. Yes. Now, we are taking one example here, the formation of the water. So, when hydrogen reacts with oxygen, it forms water. So, how many atoms of oxygen here involved, how many atoms of hydrogen here involved, and how many molecules of the hydrogen and oxygens are involved? From the chemical equation we can get to know all the answers. So, first we can see here that this number, this 2 represents the number of molecules and this 2 represents the number of atoms. So, how many numbers of molecules here, how many numbers of hydrogen molecule here? It is 2 hydrogen molecule, and since there is no number here, so that means it has 1 molecule of oxygen. So, when 2 molecule of hydrogen reacts with 1 molecule of oxygen, 2 molecules of water will form. Now, how many number of atoms? This 2 and 2 will multiply, and so there is the number of 4 hydrogen atoms reacts with 2 oxygen atoms, and how many hydrogen here form? 4 hydrogen atom and 2 oxygen atoms. So, we can easily say that the number of hydrogen in the left side and the number of hydrogen in the right side is equal. Similarly, the number of oxygen atom in the left side and the number of oxygen atom in the right side is equal. In the chemical equation, there are basically 2 parts. This part is called the reactant side and this part is called the product side. So, when the reactants combine together, a new product will form. Now, here it is written, that is the word equation. Yes, when carbon reacts with oxygen, it forms the carbon dioxide. It is written in the word form. When we will write in the chemical equation form, we will write like this. C represents the symbol of carbon element, O2 represents the symbol of oxygen element, and here it forms a compound, that is CO2. Now, what is reactant and what is product? The substances that are involved in the chemical reaction are called the reactants. Here we can see here this copper sulfate and NaOH, these are the reactants. That means this copper sulfate and NaOH are called the reactants. When they combine together, they form 2 products, sodium sulfate and copper hydroxide. This sodium sulfate and copper hydroxides are called the product. Why? Because these are the resultant of the reactions, copper hydroxide and sodium sulfate. Now, the chemical reactions may be of various types. Maybe one reactant breaks into 2 or more products, like here we can see calcium carbonate. So, when calcium carbonate is heated, it forms calcium oxide and carbon dioxide will liberated, carbon dioxide gas will liberate. Here it is, number of reactant is only 1, that is the calcium carbonate, and here the number of product is 2, that is calcium oxide and carbon dioxide. Second type of reactions may be 2 reactants and 1 product, like we have taken the example of ammonia, this is one of the reactant. The second reactant we have taken hydrochloric acid, that is HCl. So, when both of the reactants combine together, they form ammonium chloride, NH4Cl, they form ammonium chloride. So, here 2 reactants combine together to give the 1 product. Another type of chemical reactions may be when 2 reactants and there is the formation of the 2 products. For example, sodium sulfate when react with the barium chloride. So, 2 products here form barium sulfate and sodium chloride. Fourth one may be 2 reactants and 3 or more products can form. Yes, maybe it can be possible. Potassium permanganate KMnO4 when reacts with hydrochloric acid, there are many products formed here. Potassium chloride, manganese chloride, water and sodium chloride. So, how many products are here? 1, 2, 3, 4. So, the reactions may be of different types, maybe of 1 reactant and 2 products, 2 reactants, 1 product, 2 reactants and 2 products, and 2 reactants and 3 or more than 3 products. So these are the examples of the various types of chemical reactions. Now next we see about the balancing of the chemical equation. The first question comes to our mind, why we balance the chemical equation, and does this equation balanced one or not. First we will see here, this is potassium chlorate. When heated it gives potassium chloride and oxygen. Now how many atoms of potassium here? 1, chlorine 1 and oxygen 3. In the product side 1 potassium, that means same, chlorine is also 1, but here the number of oxygen atom is 2 and here the number of the oxygen atom is 3. That means this equation is not balanced. This implies that this does not follow the rule of law of conservation of mass. Now study about what is balanced chemical equation. So balanced chemical equation means the number of atoms or the molecules in the product side must be equal to the number of the atoms or the molecules in the reactant side. That means LHS must be equal to the RHS side. Here we have taken one example of the potassium chlorate, and when it is heated it gives potassium chloride and the oxygen atom. So here the number of potassium is 1, here also the number of potassium is 1 in the product side, here in the reactant side the number of chlorine is 1 and the number of chlorine is here also 1, but here the number of oxygen atom is 3 and here the number of the oxygen atom is 2. That means it represents that there is the chemical change, but this reaction is unbalanced, and unbalanced means the total number of atoms of each element on the two sides are not equal. The atoms on both the sides or the molecules on both the sides of the reactants and the products are not equal. This unbalanced chemical equation would imply that atoms have been created or destroyed, and it does not support the statement of the law of conservation of mass, which states that matter is neither created nor destroyed in the course of chemical reaction. So we balanced the chemical equation. Now here we have taken one example, P4O10 when reacts with water it gives 4H3PO4. So if you see here is the number of phosphorus is 4, here the number of phosphorus is only 1. Just remove this 4, now the number of phosphorus is 1. Here the number of oxygen atom is 10 plus 1, that is 11. Here the number of oxygen atom is only 4. Here the number of hydrogen atom is 2 and here the number of hydrogen atom is 3. So to balance this chemical equation, what we will do, we will first write down the names of the elements here, and first we will give the preference to the metal elements. So in this reaction there is no metal, all are the non-metals. Phosphorus is also non-metal, oxygen is also non-metal, hydrogen non-metal. So after the giving preference to the metal, if there is no metal, we will write the name of the non-metal element. So the first non-metal element we will write here phosphorus, then we will balance the oxygen of the chemical equation, then we will balance the hydrogen of the chemical equation. In this before and after, before represents the reactant side and after represents the product side. How many atoms of the phosphorus here? It is 4. How many atoms of the oxygen here? It is 11. This 10 and this plus 1, 11. And how many atoms of the hydrogen here? It is 2. Product side, the number of phosphorus is 1, the number of oxygen is 4 and the number of hydrogen is 3. Now if we multiply this with 4, the number of phosphorus with 4, we can write it here 4. If we write here 4, that means the number of atoms of phosphorus becomes 4. This 4 will be multiplied with this hydrogen, 3 hydrogen, that means the number of hydrogen now becomes 12 and the number of oxygen will become 4 into 4, that is 16. So 4, 16 and 12. So now again to balance we will add here 6. So if we will add here 6, now the 6 into 2, the number of hydrogen atoms become 12. Here also 4 into 3, the number of hydrogen atom is 12. So the hydrogen is balanced. Phosphorus is also balanced. This 4 phosphorus and this 4 phosphorus and this 6 oxygen plus 10 oxygen, that is 16 oxygen, and here also 4, into 4, that is 16 oxygen. That means all the 3 elements in the chemical reactions are now balanced and it comply the law of conservation of matter. So when the chemical equation is not balanced, it is called the skeleton form of chemical equation. When the chemical equation is balanced, it is called the balanced form of the chemical equation. Now the next question comes to our mind, that what are the information a chemical equation can give? Now first of all, with the help of the chemical equation, we can say the actual result of the chemical change. Yes, for example, if you are taking, when sodium hydroxide reacts with the sulfuric acid, sodium sulfate and water is formed. So this is the product. We can easily say that there is the chemical change here, because while sodium hydroxide reacts with the sulfuric acid, sodium sulfate is formed, the new product is the sodium sulfate. This is the kind of the chemical change, and there is a production of the new product. Second information we get about the reactants involved and the products formed as a result of the reaction. In the formation of the sodium sulfate, there are 2 reactants. The first reactant is the sodium hydroxide and the second reactant is the sulfuric acid. So we get to know that sodium hydroxide reacts with sulfuric acid, sodium sulfate will form. Third information we can get about the number of the molecules of each substances taking part and formed in the chemical reactions. Yes, about the number of the molecules. Here NaOH, so the number of molecule is 2. This number represents the number of molecules. So when 2 molecules of sodium hydroxides reacts with 1 molecule of sulfuric acid, 1 molecule of sodium sulfate and 2 molecules of water will form. We can easily find out from this reaction, from this example, that how many molecules of each substance is taking part in the chemical reaction. Next information it conveyed, that about the chemical composition of the respective molecules. Yes, if you are knowing the formulas of each and every elements, if you are writing in the chemical equation form, we can easily get their compositions also. That means sodium hydroxide contains sodium, oxygen and hydrogen. Sulfuric acid contains hydrogen, sulfur and oxygen. Similarly, sodium sulfate will contain sodium, sulfur and oxygen atoms. So it clearly denotes the chemical composition of the respective molecules. It also tells about the molecular mass. In the next slide, we will study about the molecular mass and the relative atomic mass. But if you are knowing the atomic number of the sodium, atomic number of the oxygen and atomic number of the hydrogen, combinedly we can find out the molecular mass of the sodium hydroxide. Similarly, if you are knowing the atomic number of the hydrogen, atomic number of the sulfur, atomic number of the oxygen, we can easily find out the molecular mass of sulfuric acid. It also proves the law of the conservation of mass. Yes, the total number of atoms of sodium or oxygen or hydrogen or sulfur is equal in both the sides. That means is equal in the RHS side and is equal in the RHS side and is equal in the LHS side. That means reactant and the product sides are equal. So it proves the law of conservation of mass. Now coming to the topic relative atomic mass. Why we called it as the relative atomic mass, or why not only the atomic mass? It is also known as the atomic weight. Since we know that the atoms are very small and cannot be seen or weighed directly, that's why we choose a standard atom as a unit and then relate the masses of the other atoms to it. Scientists have found that the mass of one proton is 1.66 into 10 to the power minus 24. 66 into 10 to the power minus 24. 10 to the power minus 24. Since hydrogen is the lightest element, scientists have seen that hydrogen has only one proton. So they considered the mass of the hydrogen atom as 1.66 into 10 to the power minus 24 grams. But since it is a very complicated number, scientist has taken it as 1 AMU. 1 AMU means 1 atomic mass unit. So how do we calculate the mass of the other elements? Other elements contains both protons and neutrons, and it is very difficult to calculate it, but it is very easy to compare with the mass of the hydrogen atom. That's why they use the term relative, which means reference to the other elements. In the beginning, hydrogen atom is chosen as the reference unit, but it was found that hydrogen is not reacted with most of the element, and that is why we shifted to the other element, that is the carbon 12. So scientists told that the mass of 12 hydrogen atom is equal to the mass of 1 carbon atom. We can understand this from this diagram. We will take a beam. Here is 1 atom of carbon and here is 12 atom of hydrogen. It says that 12 hydrogen atom is equal to the mass of the 1 carbon atom, and so we take as the mass of the carbon as 12 AMU. Mass of the carbon as 12 AMU. Now later on the scientist has chosen the carbon as the standard element. Why? Because carbon easily react with most of the elements and it was easy to find out the atomic weight of the other elements. So it is taken as the reference to calculate the relative atomic mass of the other element. Now here we see the definition of the relative atomic mass. The relative atomic mass or the atomic weight of an element is the number of times one atom of element is heavier than 1 by 12 times the mass of carbon 12. That means the element is compared with the carbon 12 atoms to find out its atomic mass. Now the next topic is about the relative atomic mass. So if we know the relative atomic mass, we can easily find out the relative molecular mass. What is relative molecular mass? It is a sum of the relative atomic mass. So here is the one molecule of carbon dioxide. So if we know the relative atomic mass of carbon, that is 12, and the relative atomic mass of the oxygen, that is 16, and here it is the 2 atoms of the oxygen, so we multiplied 16 with 2. So now we add both the atomic masses of both the elements, that is of the oxygen and the carbon, so it is 44. So relative atomic mass says, or the molecular weight of an element or a compound is the number that represents how many times of one molecule of the substance is heavier than 1 by 12th of the mass of an atom of carbon 12. So if we know the relative atomic mass, we can easily find out the relative molecular mass of the compound or the molecules. Our next topic is percentage composition. Here we take the example of water. Percentage composition of a compound means the percentage by weight of each element present in it. Take the example of water. Here the formula of the water is H2O. The mass of the hydrogen in water is 1, and here the number of atom is 2, so we multiplied it with 2, so 2 gram per mole, and here the mass of the oxygen in the water is 16 and the number of atom of the oxygen is only 1, so it is multiplied by 1 and it is here 16. So if we calculate the percentage of hydrogen in the water, what we will write? The part of hydrogen atom in the water molecule, that is 2, divided by the total molecular weight of the substance. So total molecular weight of the substance is 18. So we divided by 18 and then to find out the percentage we multiplied it with 100 and we get 11.1%. That means the percentage of hydrogen in the water is 11.1% and the percentage of oxygen in the water is 88.9%.